Okay, hey, welcome back, class. In this unit, we're going to talk about solutions and chemical systems. For the next few videos, we're going to be camping out on the understanding of chemical solutions and their properties. If I could break our learning objective for today's video down, this is what it would be. That you would be able to define what chemical solutions are and describe the components in terms of solubility. So the first thing we're going to talk about is what is a solution. A solution is a homogeneous mixture. This means the components are uniformly dispersed throughout the substance. Think of your mouthwash. Whether you freshly open a new bottle or it's halfway done, the solution of mouthwash looks and tastes the same. Mixtures are composed of two parts. The solvent is the largest portion of the solution, and it is what is going to do the dissolving, while the solute is the smaller portion of the solution and is what is being dissolved. Think of sugar and water. Your sugar is the smaller portion, and it is what is going to be dissolved. So that is going to be considered your solute. While the water accounts for a majority of the solution, a much larger portion of it, and is going to be doing the dissolving. In this case, water would be the solvent. Solutions do not always have to be solids dissolving in liquids. You can have two gases coming together, one dissociating into another to form a gaseous solution. An example of this would be the air around you. The air around you is made up of gases such as nitrogen, oxygen. Though these gases consist of different elements, you cannot distinguish the difference between the two gases. That's what makes it a solution. You can also have two solids coming together to form a substance such as brass. Or even you can mix states of matter together and have solutions such as liquids and gases coming together to form a solution in a Coke or a pop. In chemistry, when a substance is dissolved in water, it is called an aqueous solution. So do not let this terminology throw you for a loop. All it is saying is water is the largest portion of the solution and is dissolving or dissociating the other portions. Our last bit of terminology before we get into the conceptual portion of this lecture are the words soluble and insoluble. Solubility is the ability for a substance to dissolve. If a substance is soluble, then the substance is able to dissolve. But if the substance is insoluble, then we can't dissolve it or dissociate it. For example, sugar is soluble in water, but we cannot dissolve oil, so oil in water would be insoluble. Now that we got the terminology out of the way, let's talk about what happens when a substance dissolves within a solution. In a glass of water, water molecules interact with each other and form hydrogen bonds between each water molecule to water molecule interaction. If we want something to dissolve in water, then it must take the place of the interaction between these two water molecules. This means instead of having water molecule to water molecule interactions, we would have to have water molecule to solute interactions. What makes a substance soluble or insoluble in this glass of water is whether or not a substance can take the place of the water-to-water interaction. If we can split water molecule to water molecule interactions and create interactions which could continue chains of water molecules interacting together, then it can successfully be dissolved in an aqueous solution. This usually deals with the size of a molecule. For example, it's a lot easier for a sugar molecule or for sugar in general to fit between water molecules than a large oil molecule. This concept leads us to the saying, like dissolves like. This basically means the properties and polarity of the solvent and solute need to be similar. Polarity is the ability for a substance to create a partial charge on opposite terminals of itself. In other words, a molecule, due to its geometry or orientation, will have a section that is more positively charged than another section. For example, each water molecule has a partial positive portion and a partial negative one. Those sections have the ability to act on other molecules according to their charges. For example, the partial negative portion of the water molecules will bind to the partial positive portions of other molecules. If the water molecules can surround other molecules, then they can cause it to dissolve and create a solution. I feel this is enough to throw at you for this video. I hope this helped you out and keep up the work in the classroom. See you next time.